catch up. My name is Osama Naseem. I am a senior product manager for Amazon MSK. And today we will be, let's take a look at what we have on the agenda. So we'll begin by taking a step back from MSK and talking a bit about what real-time analytics is and why it's important, and why data streaming is important. It's a 200-level session, so we'll start slow, and then we'll build up slowly. We'll then transition into what is Amazon MSK, for those who may not be fully aware of what MSK is and what it can do for you or what it does for you today. We'll also peel the onion a little bit and tell you what our customers have told us in terms of what we can do more of or what we can do better, and what prompted us to develop this new capability. And then we'll take a tour of what this new capability is and what it does and how it works. Great, so without further ado, let's dive in. So the first question that I want to tackle as part of this presentation is why data streaming? Why are we talking about here? So data is at the heart of every business today. I think we all know this. That's why you guys are here. Every business is producing tons of data. This data could be generated through customer interactions, through business processes, through financials. And businesses have realized that they can generate a ton of value from this asset. It's almost an asset. It's actually an asset. But to deliver or to create value out of this asset, you need to use it well. And this data is being produced in high volumes and from a variety of data sources today. So it's highly varied. It's being produced at high volumes. It's coming in at high velocity. So for you to be able to create value, you need tools that you can first use to store them, and then analyze that data to draw insights, which will then give you actionable insights that you can then implement and improve your business outcomes or customer experience or what have you. So some of the popular tools that are already in a lot of customers' tool belts are data warehouse, where you can dump your data in the form of data tables, run queries against them. Typically, these are used to run reports and look at the business historically, typically at the day end or daily reports, etc. And then data lake, which you can sort of bring in data from all over the place and use it to feed off machine learning models or what have you. But we also know that the value of data diminishes over time. And it diminishes pretty quickly, rather. So if I can draw your attention towards the screen, you'll see 4 bars here. The leftmost is the real-time bar, which is basically telling you that the value of data is at its maximum if it's used right away. Now, obviously, we all know there is no such thing as real-time, but the closest you can get to real-time, you can draw maximum value out of it. You can take preventative actions, such as maybe something is about to go wrong. Maybe your alarms are firing off, and if you can take action based on that, you can prevent a system outage. You can take predictive actions. Maybe a shopper has visited your website, and certain actions, such as views or clicks, can generate insights into recommendations that you can show on that page. Or maybe a gamer who is playing a game right now is taking certain actions, and based on that, you can show an in-game purchase offer. Now, if you do not react to those things in real time, that data in real time, then that opportunity is lost, and you can't really benefit from it. So the value extremely goes away within a very short window of time. And then, as you go further towards the right, on the order of minutes and hours and days, it becomes much more reactive and historical, which has its own place in business today, but still at the same time, not as beneficial as something on the left. So tools today, as we discussed, are great for, have over time quickened themselves, have basically worked on processing this data faster and faster. And that has taken the form of micro-batching, analytics over a very short window of time, but it's still looking back reflectively. What is missing today, or what was missing till data streams showed up, is the ability to process this data real time. So as records come in, you're able to process them one at a time and draw insights out of them. And that is what will give you near real-time insights and allow you to basically capture all that value on the leftmost bar that we just saw. And that is where data streams become very important. These are tools that can ingest a large amount of volume of data at extremely high throughputs, and then make them available for your consuming applications at really low latencies. We're talking about single-digit millisecond latencies. Wow, I got that right. So that's where data streams becomes important. AWS obviously offers multiple solutions in this space. We have Kinesis Data Streams, which has been around for a while, that allows you to ingest petabyte scale data and make it available for you to analyze with a variety of other AWS services, such as AWS Lambda, Amazon Kinesis Data Analytics, et cetera. And then another popular tool that was, that has been popular sort of became popular at the same time and has been around is Kafka. So Apache Kafka, it's an open source event streaming platform, which is basically an open source project under the auspices of Apache Kafka Foundation. It is much like Kinesis. It offers low latency and extremely high throughput, and it can fan out to thousands of consumers without really affecting the performance of your system. So that's the beauty of it, where you can fan it out to so many consumers. Let's say you have you need to process that data across multiple microservices. Let's say an event was produced by one producer and multiple consumers need access to it. You can now, with Apache Kafka, you can make that data or that event available to literally thousands of consumers if you want, without suffering any performance impact on your cluster. And then, given all this, what eventually it means is that it enables use cases such as messaging, event stream processing, so that you as a customer can then implement microservices messaging. So you have, let's say, maybe you're moving more and more towards async event processing between within your data systems. Maybe you want to implement streaming ETL, and you want to process and analyze data as it's being produced. Maybe you have IoT devices in the field that are producing this data, and you want to have actionable insights that can be sent back to those sensors to take actions based on the data that's being generated. So Apache Kafka helps build all those use cases. So back in 2018, we announced Amazon Managed Streaming for Apache Kafka based on popular demand. Customers had been telling us that, hey, we're using Apache Kafka on AWS, but running it ourselves is pretty difficult. It's at scale with high security, high availability, and with best practices. It requires deep expertise. We need to hire engineers who can run Apache Kafka, and then those engineering hours are spent managing the infrastructure as opposed to on value-added activities that can help our customers or our business. So our answer was to launch Amazon MSK, a fully managed service for Apache Kafka, and now Kafka Connect as well as of September. Let's take a look at what Amazon MSK does for you. So as we discussed, operating Apache Kafka at scale with high security, high availability, obviously is not a simple task. So you need large teams, you need deep expertise. But with Amazon MSK, you can do that without having a large team or without deep expertise. So by doing that, Amazon MSK makes Apache Kafka more accessible to your organization. It drives best practices through design and defaults and automation. So we have, over the years, learned how to operate Kafka by just doing it over and over again, and we've learned from it, and we've implemented some of those automations and some of those design best practices into our systems so that when you run Apache Kafka, you're getting the best of what we have learned so far. And that automatically ensures that your system is up and running without investing a ton of engineering hours on it. So your engineering hours can be spent on focusing on what matters. So you can instead spend that time on improving your own applications or automating your own processes or helping your own customer experiences. And last but not the least, the one thing that we focus on is obviously contributing back to Apache Kafka, which then allows us to keep this ecosystem rolling. Some of the features that Amazon MSK has is, obviously it's highly secure. So we provide multiple layers of security, such as VPC network isolation, encryption at rest and encryption in transit, multiple authentication and authorization modes. And when you create an MSK cluster, your brokers are automatically placed inside an Amazon VPC, which is short for Virtual Private Cloud. And that's the green box. And these are automatically, the VPC is owned by the service team themselves, so we ensure that we implement the best practices that AWS has learned over the years. Then it's highly available, so we take advantage of multi-AZ replication within an AWS region. So whenever you create these brokers are spread evenly in multiples of 3 across the availability zones. This is the blue boundary that you see around these brokers. Private connectivity, so data stays within the AWS network when you use Amazon MSK without being exposed to public internet. We do so by allowing you to put your brokers inside private subnets. Then we drop these network interfaces, which are these purple round circles right next to the instances you see at the bottom of the screen. And these network interfaces allow that the traffic stays within the AWS network and doesn't leave the AWS network and doesn't traverse over the public internet. So that way, the connectivity is private all the time. And then we are fully compatible with Apache Kafka. So you may have applications running on your prem today. You may have used Apache Kafka before. So the API that you're using today, whether it's the producer API, the consumer API, the Kafka Streams API, the Kafka Connect API, all of them work seamlessly with once you move your workload over to Amazon MSK. So it's fully compatible. Then some other features I would like to touch upon. We have deeply integrated with other AWS services. So I've already mentioned that you can use IoT as a data source. You can use AWS Lambda as a data sink. You can use you can do schema management with AWS Schema Registry, stream processing with Amazon Kinesis Data and Analytics for Apache Flink. And you can integrate with other services upstream and downstream. And we obviously have integrations with AWS IAM, CloudTrail, et cetera. So there's a vast variety of AWS integrations that are available, and will continue to be, we will continue adding to this list. You can scale brokers in and out. You can scale storage, and we provide observability through CloudWatch and through open monitoring for Prometheus. And last but not the least, we also offer rolling version upgrades. So you have complete control over your Kafka environment when you use MSK. You can basically add whatever, or you can use whatever Kafka version you want to use. We typically try and make the latest Apache Kafka version available within 7 to 10 days. If it's a major version release, may take a bit longer, but our goal is to have it available within, at max, 30 days for you to be able to use. And then you can trigger a rolling version upgrade, which means that we take one broker out at a time, apply a version upgrade to it, and then bring it back online. So that way, your cluster doesn't face any outages. All that is great. And you might be wondering, why are we talking about Amazon MSK here? That service has been around for 3 years. And you'd be right, but I just wanted to sort of provide a quick overview of our journey, where we've been so far, and how we've arrived at this stage. So what have customers told us that prompted us to actually go and build this capability? So I'll share with you a few pieces of customer feedback that we've received. These are anonymized, and but these are actual feedbacks that we received. So one customer, they have sales a few days every month. And based on that, they have demand that fluctuates. And one of their asks was that, hey, having an auto-scaling feature will reduce our operational overhead. We have to continuously monitor our capacity and then auto-scale in response to our increased demand. And if we have an auto-scaling feature, you'll help us reduce overhead. Another customer said that we would like to have once we're scaled out, and for those of you who are familiar, Kafka has partitions which are spread across your brokers. And they said, when we scale out, we want to be able to balance those brokers. So basically, in effect, load balance across the increased set of brokers that we have. Or if when we scale down, we want to be able to load balance across a reduced set of brokers that we have. But we don't want to do that ourselves. It's operational overhead that we don't want. I mean, it's a pretty involved activity to do it ourselves. Or we have to have some kind of tool that's automated and that's running it, but then we own that automation. So can you help us rebalance partitions after a scaling event? Another customer who has a banking application, they said that our application gets used mostly during working hours, during daytime, very little activity during the evenings, very little activity during weekends. And this is our traffic pattern, the line in blue. And then as a result, we have 3 options. We can either just provision for our max and pay for that idle capacity over the weekends or at night, or we can scale up and down ourselves, which will be error prone and very manual. Or we can build automation, which will respond to certain metrics of utilization of our capacity and then scale our capacity up and down in response. But again, that is code that we'll have to manage, application that we'll have to run ourselves and keep up to date, and bugs that we'll have to resolve. Then there's this kind of workload, which is clusters that are sporadically maybe used for development and testing. And somebody might be developing an application, they want to test it at certain times during the day, during the week, and you see these bursts of activities. But then most of the time it's idle, especially on weekends, at night, and at random times during the week. It's unpredictable. And then you may have a workload that is humming along nicely. You have provision capacity, which has enough buffer, and you're OK paying for that idle capacity. But suddenly there's a peak. There's some spike in traffic, and as a result, now your provision capacity is not enough, and your customers get throttled. And your customer experience gets affected. Your website might slow down, your application might go down. And as a result, we want to be able to scale out in as needed so that we're able to avoid these bad customer experiences. So the 3 things that I got out of it, or 4 things that I got out of it, is that customers need or want us to do better at auto-scaling. They want us to provide more automation, especially around partition management. And they want, they don't want to pay for idle capacity. So they want it to be cost-effective, especially for the workloads that we just saw, where capacity might be used sporadically or at a certain pattern, and then at other times it's idle and it's sitting doing nothing and you're just paying for it. So they want us to be more cost-effective. So then we went back to the drawing board, and we're like, OK, how can we help solve this problem? We want to be able to solve all these problems together. Obviously, we can do it individually, but then that won't really yield the true customer experience that we want to give our customers. And obviously, the answer, you guys automatically know, is Amazon MSK Serverless. So that is something that we launched yesterday in public preview. It's available in US East Ohio, and it's something that solves all these problems. It is, and let's take a look. I mean, don't listen to me. Let's take a look at this video, and hopefully that will answer some of your questions.
Organizations are increasingly
Can I get
adopting
the volume up,
Apache
please?
Kafka to capture and analyze real-time data streams from sources like IoT devices, website click streams, financial systems, and database logs. Tens of thousands of customers use Amazon MSK, a fully managed service for Apache Kafka, to build and run highly available, secure, and scalable applications. However, for unpredictable or unknown workloads, provisioning cluster capacity can be a guessing game. Introducing Amazon MSK Serverless, a serverless option for Amazon MSK. With MSK Serverless, you can run Apache Kafka without managing cluster capacity. Create an MSK Serverless cluster in just a few clicks, using new or existing Apache Kafka applications to stream data. And MSK Serverless automatically provisions and manages the required resources, giving you on-demand streaming capacity and storage. Scale your application as streaming data volumes change, without continuously right-sizing clusters or worrying about over-provisioning. Plus, with MSK Serverless's throughput-based pricing, you only pay for what you use. Learn more on our website.
All right. So here's what I saw in the video. So first of all, Amazon MSK scales up and down automatically, so you don't have to manage capacity yourself. You don't have to provision it. You don't have to worry about when to scale it, when not to scale it, when to scale it down. So it, in effect, provides you on-demand stream capacity. I want to draw an analogy to how we all, to an example that we all interact with almost on a daily basis. You walk into a room, you need to turn on the light. You turn on the switch, and lo and behold, the light turns on. That's 100, probably 200 years of technology innovation at play. But basically what's happening is that electricity on demand is coming to your home without you having to worry about, do I need to power up my generator as well? And that's the experience we want to provide with Apache Kafka, where your applications may need capacity at any point in time, and all you need to do is start producing data or start consuming data, and that capacity will be available by default. You don't have to worry about, oh, do I need to crank up my power generator and get that capacity? So it's on demand. Then, so let's take a look at what that means. So basically, with each cluster, you'll get up to 200 Mbps of write capacity. So your producers can collectively write at 200 Mbps per Apache Kafka cluster that's managed by Amazon MSK Serverless. You also get 400 Mbps of read capacity. So you can consume, almost at 2x the rate. And then, to allocate enough capacity for each partition for it to scale up and scale down so that, an application is not drowning out other applications, we allocate each partition 5 Mbps and 10 Mbps of write and read capacity from within that 200 and 400. So your partitions can scale up to all the way up to 5 Mbps of write throughput and 10 Mbps of read throughput. Then we have throughput-based pricing. So that's just like, you would use, going back to the electricity example, you have throughput-based pricing. You have some base costs, which allows us to maintain the service, which allows us to maintain your server, beg your pardon, your MSK resources at the back end, or your Kafka resources at the back end. And outside of that base cost, all usage is pay per use. It depends on the number of partitions you create. If you create more partitions, it will scale up. If you create fewer partitions, it will scale down. And then if you send more data, you pay by GB, you pay per GB data written in, and you pay per GB data consumed. And then the third thing depends on how long you retain it for. So if you're retaining it for a long time, you pay more. If you're retaining it for a short time, you pay less. So that's how, the pricing works, where just like electricity bill, you only pay for what you use. Yes, there is some base cost because obviously we are maintaining that cluster for you, but then outside of that, your total cost of ownership closely mirrors your usage. Then auto-partition placement, that was one of the other things that we heard about. So this, you might wonder that you're scaling out, scaling in, what happens to my partitions? The service takes care of all of that. You don't have to worry about it. The service will, move partitions around when it detects that, a particular broker is heating up. It'll move partitions off of it when it thinks it's cooling down. So I think from that point of view, your applications can just keep producing and keep consuming without having to worry about, if my application load scales up, what happens to my partitions? Or if I create a new partition, do I have to worry about where it goes? Or do I have to worry about how it gets placed on my brokers? No, you don't. You don't have to manage any extra tool. You don't have to manage any extra piece of script to control how partitions are placed across your brokers. Actually, you don't even see the brokers. Then it's fully compatible. So you might be wondering, that's all great, but I want to keep using my applications. Yes, you can. It's fully compatible with open source Apache Kafka. You can continue to use your producer APIs, your consumer APIs. So just like MSK, MSK Serverless is also fully compatible. You don't have to worry about what happens with my applications. It's obviously similarly secure. So you might be wondering what happens to security. So I'll take you back to that diagram that we saw with MSK. And this is for MSK Serverless. So the service itself sits inside the VPC, which is the green box at the top of the screen. And then your clients can sit inside your own VPC, which is the green box at the bottom of the screen. And we provide the same layers of security as MSK does. So there's network security through sort of VPC isolation, subnet isolation. There is security on ingress and egress through IAM Access Control and authorization. And then there is security with encryption in transit and encryption at rest, all part of this service. And then, we have the same high availability. So, it's not like if an AZ goes down, suddenly your clients cannot communicate with the cluster. So how we ensure that is that as part of your creating a cluster, and we'll see if, we'll see a cluster demo shortly, is that when you create a cluster, we require you to provide at least 2 subnets in which you'll place. You may have a client on only one subnet, but we also require to provide a backup subnet so that if that AZ in which your client is, assuming your client is not provisioned for high availability already, which would be against best practices, but assuming that it's not, and you want to bring it up in case of an AZ failure in a backup subnet, you would have had provided that as part of cluster creation, and we would have created a network interface in that AZ so that if you bring it up in another subnet, it can still communicate with the cluster. So there is no outage. If an AZ goes out, you can still communicate with the cluster. That's not a problem. So what does all that, give us? It basically tells us that, Amazon MSK is simple to use. MSK Serverless is simple to use. You can get started with a few clicks, and we'll see a demo quickly, and I'll show you how simple it is. You can create a cluster in a matter of clicks within the console or through an API call. You can get started using your existing applications, so you don't have to worry about, oh, do I have to refactor my applications? Do I have to code it again? No, you don't. It lowers operational overhead, so you can use those engineering hours to solve your own customer problems. You don't have to worry about provisioning brokers. You don't have to worry about scaling them as your workload demands change. And then all that, what it means is that it's highly cost effective, because especially for the workloads that we just saw, because now what you're doing is that your total cost of ownership is closely mirroring your usage. So when there are times when your cluster is, when your applications are not producing any data or not consuming any data, you're not paying anything other than the base cost. Before we go there, I think I'll just like to quickly do a quick demo of cluster creation, and then show you how to basically do this. So what you have on the screen is the MSK console. You can basically go there in the AWS console, find Amazon MSK, and just like you would do today, you can hit create cluster. The screen you will see in front of you is basically just a create cluster flow, standard flow that we have today. Within that, the first choice you get is to either quick create or custom create. Quick create basically just implements a lot of best practice defaults and allows you to just create a cluster in a single click. But for the purpose of this demo, we'll go through the custom create option. Then we pick a name. So let's just say it's demo. And the next thing is where you make the choice of the type of cluster you want. So if you were to choose a provision cluster as you would do today, this choice doesn't exist today or didn't exist till yesterday, you would choose a Kafka version, you would choose the number of brokers, the type of brokers, and then you would also choose storage and configuration. All this you don't need to do if you're using serverless. So you just click here, all that goes away. And it tells you that you get, with each cluster, you get up to 200 Mbps of, as we discussed, write throughput, 400 Mbps of read throughput. Right now, there is a 250 GB max storage per partition limit, but this will be relaxed once the service matures and we go towards GA. We don't have a final timeline yet, but yeah, close to GA, we look to relax this limit. And then same on the number of partitions. Today, you can create up to 120 partitions per cluster, but this limit is also within our plans to relax. And then you click next. This will take you to the network configuration page. This is where you can choose the virtual private cloud that you want to attach to your, or basically in which you want to place your clients. Basically, whatever VPCs are in your region, you will see it in the dropdown. I'll choose my default one for now. And then, as I mentioned, you can attach subnets or choose subnets, which will ensure high availability. So, the first subnet, let's just take, I'll do it in US East 2A and the associated subnet with it. And then, as a backup, I'll also attach US East 2B here, so that MSK, the signals to MSK that you need to create a network interface in 2B as well, even though I might not have a client there right away. And you can add up to 3, so you can add one more, or you can choose to limit it at 2. And then you can choose a security group. The security group, obviously, it provides another layer of security. It sort of, you can control who has access to these subnets or these brokers or these clusters that you have. And you can choose up to 5 VPCs. So, as you may have clients spread across different VPCs, you can choose up to 5 of them and add them here so that clients across those 5 VPCs can communicate at the same time with the same backend MSK cluster. And then you click next. This just tells you the IAM Access Control method is activated on this. Right now, it's the only one that's available. You can use IAM role-based authentication. So what will happen is that your clients will need to assume a role, an IAM role, to be able to communicate with the cluster. And the IAM role will then have an attached policy with it. With that policy, you can control fine-grained access to the different cluster resources. So, for example, you can control which clients have access to writing writing data, which clients have access to reading data, or both, and which clients have access to basically creating a topic, and which clients don't. So, I think you can go down to that level of detail, and many more actions that are well detailed in our documentation. The next step is where you would just look at, it just tells you you're also going to publish a few metrics. So, as I mentioned, Amazon CloudWatch is something that Amazon MSK integrates with. So MSK Serverless also integrates with CloudWatch. During preview, you'll have a set of 8 key metrics, bytes in, bytes out, messages in, some consumer lag metrics that you can monitor and see how your cluster is performing. And these metrics are published by default. They're published at no additional cost, so they're included in the cost of the cluster. You can tag your cluster, and then the next screen is just a review screen where you can just view everything and make sure it lines up with what you wanted to do, or if you want to edit something, you can enter an edit flow and go back and change it. And then the best thing is that the time to create a cluster is now come down to 5 minutes. So you will be able to have a cluster up and running within 5 minutes. I'll hit create, but we won't wait for 5 minutes, just like a cooking show. I have clusters that are created from before. So this is there are 2 demo clusters that I created beforehand. One is the serverless cluster, and the other is the provision cluster. And I'll quickly go into sort of an IDE and show you guys how this looks like in terms of producing and consuming. So the first step that I'll do is I'll obviously connect to my client instance, which is, hold on. What's happening? Sorry. Let me. So I'll basically fire up 2 client, I'll connect 2 client instances in 2 parallel windows, because on the left side, we'll have a console producer running, which will produce messages, and on the right side, we'll have a console consumer running, which will show you those messages that we'll produce. Then I'll basically set the environment variable for the bootstrap string. First, we'll produce messages to the provision cluster that you would do today. That you would probably be used to using. So, I have the bootstrap string here. And then same on this side. So we'll go into Kafka bin directory, set the environment variable for this, and then this. And then I'll create a topic. So I'll quickly create a topic which will allow me to sort of demo produce and consume. And hopefully this works. Yep. So MSK Serverless demo is the name of the topic, and we just created that in our provision cluster, ironically. Next is to fire up a console producer in here. What's happening? Console producer. Sorry, my bad. Yep, and then we'll also fire up a console consumer on the other instance. And hopefully this works. Yes, it does. Okay, so now let's exit this. Let's exit this, and then what I want to quickly show to you is we can literally produce the same. We can literally use the same producer and consumer with the serverless cluster just by changing the bootstrap string and also creating a similarly named topic. So let me just change the bootstrap string to the one we have from the serverless cluster. You can just pick this from the console. I have it ready here so that we're not spending too much time on it. And then same here. Next step is to create the topic again. Then fire up a producer. producer. Again, dot, wow. All right, so we have the producer up and running. Let's do the same with the consumer. And then again, hopefully this works. It does. Okay. So yeah, I think in short, what I just demonstrated to you guys was that we took a client, we fired up a client, we fired up a console producer and a console consumer, and produced and consumed from a quote-unquote provisioned cluster. And then we did the same thing by using the same client and just changing the bootstrap string and then producing it and consuming it from a serverless cluster. So that demonstrates to you that we just demonstrated how the cluster was created. So it's easy to create and easy to get started with because you can use existing applications. And it's extremely easy to get started. So then this brings me to sort of like an important juncture in this presentation, which is, great, we have another new capability, and AWS continues to add new capabilities, but how do I choose? And when to use what? And you've just told me MSK is great, you've just told me MSK Serverless is great, so where do I use what? So I think there is no one-size-fits-all answer, unfortunately, as unsatisfying as that may be. But what I can leave you with is some guidelines, right, of what you can do and how you can use this. So I think if you look at the left-hand side, MSK, which allows you to control the number of brokers you have, the Kafka version you want to run, the Kafka configuration you want to run, and gives you a lot of APIs to sort of play around and fine-tune your configurations. It basically means that you have more control over your environment. So if you're seeking more control over your Kafka environment, you want to know how to run this. You know how to run this. You want to control it because you believe you can do it best. Then go for it. Use MSK. It gives you a lot more control. Over time, we have added more control. So we've given you new APIs such as reboot instance, reboot broker, et cetera, et cetera. So we've continuously exposed more controls, and we will continue to do that. And we'll continue investing in that service. So it gives, if you have more control, by all means, go use MSK. If you have stable and predictable throughput, so if your applications produce throughput at a very stable rate, they don't fluctuate much. Maybe they go slightly up and down depending on time of day or time of month, et cetera. But then at the same time, it's relatively stable. Then use MSK. Have that slight buffer capacity, and you would still not be paying too much on a $1 per GB basis. And then last but not least, because we have certain limitations on the amount of throughput that an MSK serverless cluster offers, if you have large workloads that are doing more than 200 Mbps of write or more than 400 Mbps of read, then yes, you may want to use MSK because you can have up to 120 brokers in a cluster, or you can have instance the size of M524 XLs on an MSK cluster. So yes, then you can use MSK, you should use MSK. But on the flip side, if your preference is to offload capacity management to a managed service, you don't want to handle capacity, you don't want to think about these are the number of messages I have on my workload, but what does that translate into number of brokers? I don't know, and I don't even know if the number of messages will stay the same. Then if you want to offload that, start with MSK Serverless. You don't need to worry about it. You don't need to do that back calculation of, okay, 500 messages means I'll need one broker. Then if you have specific types of workloads, some of the examples that we just saw, maybe you have a dev test workload that fires up very sporadically at different times during the day or at different times during the week, and you don't want a cluster running up and running at max capacity just to be able to serve that traffic. Or you may have, as we discussed, sale days or periods of high activity. And in those cases, those specific workloads, you may find it more useful to run them on MSK Serverless because it lowers your operational overhead, and it makes it more cost efficient to run those workloads because you're not provisioning for the peak. And last but not the least, you may be just getting started with data streaming. You may be getting started with Apache Kafka. And as a result, you're not fully familiar with all the terminologies. You may not be fully familiar with all the jargon. You may not be fully familiar with how best to configure it. And I think that allows you to get started much more quickly is by using MSK Serverless. It's a matter of a few clicks in the console and then configuring your clients. So yeah, that brings me to the end of my presentation. I'd like to thank you all. Hopefully this was useful, and it gives you plenty of time to run to your next session. If you have any questions, I'll wait outside, and just so that we can clear the hall in preparation for the next session. And I'll be willing to chat with you, or you can reach out to me via either of these methods, and we can have a chat about it. Thank you so much.